Hello everyone, I'm Amazira Dupada, and today in this session we are going to see the applications of differential equations, particularly in chemical engineering branch. So in this, the point is like mainly we are taking like law of natural growth and decay is the concept we are taking. Law of natural growth, it means increment. Law of natural growth and decay. So this is the concept. By using this, we will apply differential equations. And in this, I'm taking m is the mass of a particular body. It's like coming to chemical engineering, like you can say uranium or thorium, any chemical material. M is the mass of the body. Now this mass of the body, generally, when you keep in the environment, it will decay. I mean, disintegration will happen. It means it will decompose. It means its mass will be coming down with respect to time. So that is what actually decaying like. Our growth means sometimes any material accumulation may happen. It at that time the mass of that body will increase. So that is what actually growth and decay. Now the concept is this mass of the body with respect to time will vary. So d by dt, it means with respect to time. So d by dt on m. It means with respect to time, the mass of the body will vary. So how it will vary? It is directly proportional to the mass of the body at that particular instant. That is what actually concept is. It means rate of change of mass of a particular chemical element is directly proportional to the mass of the body at that time. So now dm by dt, I can write, remove proportional constant, so minus k into m. So now what I can do is variable separable I can do. It means dm, m I am bringing left hand side, minus k into dt. So both sides I apply integration. So 1 over m is log m is equal to minus k, integration of dt is t, plus some constant I am taking log c. Log m minus log c is log m by c. Log m minus log c. It means log m over c is equal to minus kd. So what will happen is m over c is equal to something e power minus kd. So mass of the body is equal to mass of the body. How it will vary? Mass of the body with respect to time is equal to c into e to the power minus kd. This is what actually your mass of a particular element, chemical element or whatever the mass of the body is varying with respect to time. This is the equation. Here c is an arbitrary constant. C is an arbitrary constant that we have seen in many cases, and only one constant will be there because of one energy storing element like. So K is real constant, T is the time, M is the mass of the body. So now the same concept of theory we will apply in the problem. Now the problem is this. Uranium disintegrates at a rate proportional to the amount. It means mass of the body. If M1 and M2 grams of uranium at times T1 and T2, find half-life of uranium. So what he is asking, like, there is a matter or body called uranium, which is generally disintegrating. It means it is decomposing with respect to time. And it has mass M1 at time T1. It has mass M2 at time T2. Now find half-life of uranium means at time half of, at what time the mass of the body become m by 2. It means half of the body, half of the mass, that he is asking. So now same theory concept only, whatever the theory we have seen, that only now I am applying. So now mass of uranium, let me take M. So let me take mass of uranium is small m. Okay. Now we know the formula. Rate of change of mass means dm over dt is directly proportional to m. Same we have seen in the beginning also. Dm over dt is equal to minus km. So dm over m is equal to minus k into dt. So both sides integration I'm applying. Log m is equal to minus kt plus some constant log c. So finally log m over c is equal to minus kt. So the equation is small m, mass of the body, is equal to c into e to the power minus kt. This is the equation. Now what are the conditions he has given? Let me write given conditions here. Given conditions. So amount of mass, if m1 and m2 mass of uranium at times t1, at t is equal to 0, your mass of the body, let us say capital M. At time t1, your mass of the body is m1. He has given. At a time t is equal to t2, mass of the body is m2. So now we can use this thing. At a t is equal to 0, now you can substitute. What will happen? M is equal to capital M only, mass. So this is the equation. Let me write equation 1. So M is equal to C into e to the power minus kt. So at a t is equal to 0, small m is equal to capital M. Now put that values in that equation. Small m is equal to capital M, c into e to the power minus k into t is equal to 0. It means c power minus 0 is 1. So that implies c is the constant is equal to capital M. One value I got. Now at t is equal to t1, what will happen? At t is equal to t1, at t is equal to t1, what is the mass? M is equal to m1. And here I will write at t is equal to t2, m is equal to m2. So at t is equal to t1, it means small m is equal to how much? Capital M1. Actually this is small m. Here also it is small m. So from this equation only, from equation 1, m is equal to m1 is equal to c into e to the power minus kt minus k into t is equal to how much? Capital T1. So M1 is equal to capital C, nothing but capital M only, M into e to the power minus k T1. Let me take this the equation 2. Now at t is equal to capital T2, what small m is become M2. So M2 is equal to C, nothing but capital M into e to the power minus k T2. Let me take this is the equation 3. Now equation 2 over 3 I can write because another constant I want to find out, that is called k. I don't know what is the value of k. So what I do is I do 2 over 3. It means m1 over m2 is equal to m into e to the power minus k t1 over m into e to the power minus k t2. That implies m will be cancelled each other. E to the power minus k t1, this become actually e power k t2. So k into t2 minus t1 will happen. So right, e to the power minus k t1, this thing will become e power k t2. So finally what you will get, e to the power k into t2 minus t1 you will get. This is m1 over m2. Now what is the k value? I want k value from this equation. So that implies both sides logarithmic. If you apply log m1 over m2 is equal to log e to the power k into t2 minus t1, nothing but k into t2 minus t1 only you will get. So finally k value is log m1 over m2 over t2 minus t1. That's it. Now you got k value, you know that, and c value we know already, we have calculated c is equal to m, we found. Now my equation, all the values I know. What is my equation is small m is equal to c into 1 implies, this is first equation, e to the power minus k, e to the power minus k small t. Now small m is equal to c, we know capital M, e to the power minus k means we know log m1 over m2 over t2 minus t1, e power minus k into small t. So this is the final equation, I got it. Now this is the final equation. But now the thing is, what he is asking, yet what is the half-life cycle of uranium? Half-life cycle means, let us say condition is half-life cycle. What is the half-life cycle is means, here m become, here small m become half of the mass of the body, so m by 2. What is the t? Let me take x. This is what actually I want to find out. So now you put this equation. Now let me take, this is the fourth equation, like, so in 4 you can put small m is equal to how much, m over 2. From fourth equation I am writing this is equal to capital M into e to the power minus logarithmic of m1 over m2 over t2 minus t1 into t. Here t is I am taking as x, that I am going to find out. So now this m will be cancelled each other. What I do is I apply logarithmic on both sides. So it will be log 1 over 2. So e to the power minus something, log e to the power minus something. So e and logarithmic will cancel. Finally, what you will get, minus log m1 over m2 by t2 minus t1 into x you will get. So now log 1 over 2 you can write like minus log 2. So minus minus will cancel. So log 1 by 2 means log minus log 2, because log 2 to the power minus 1 you can bring left hand side, so minus log 2 you will get. So minus log m1 over m2 over t2 minus t1 into x. So now minus minus will cancel each other, so x is equal to log 2 into t2 minus t1 over logarithmic of m1 over m2. As simple as that. This is the x. It means this is the time the body takes to become half of it. That is what we called half cycle of the body. So that's it. With this problem is over. I just give you a small recap. Generally, if the body is given of having mass m, it will change, it will disintegrate with respect to time. So that is what actually the equation is. Generally, firstly, we have taken like, you know, how dm by dt is directly proportional to mass of the body. With that, we have derived one equation, that is what actually small m is equal to c into e to the power minus kt. Once if this equation you got it, then you can apply initial conditions and you can solve whatever the problem they have asked. So that's it. Thank you all for watching this video.